Hi everybody. I've gotten a whole bunch of emails and private messages through Facebook and everybody asking about the brake system I'm designing for the C130. So what I want to do is take you through here a little bit of how I came up with the design and how it works, and hopefully you'll find this informative. Thanks a lot everybody for watching my videos. Have a great day. Okay, if you look right here, you'll see the whole system that I've set up here, and it actually is one of the most complicated things I've ever designed. So what I want to do first is I want to start off with looking at it through a section here, and with Fusion 360, what makes this really nice is the way I'm able to actually go in and look at different things. Now, as you look at this, you're going to notice there's a lot of parts, all the way from the spring, that's part of the suspension, to the internal guts of the brake system. Actually, you can see my bearings in here. You can pretty much see everything that I had to do to come up with this design. One of the things I want to talk about with Fusion 360 that I really like, but it really had quite the learning curve, is the all the different components that you make and the way you can name them. I think this is one of the most important things you should always remember. You can always go up on your first beginning part of the drawing, whatever you call it, and you can right click it, and my right click's not working. Oh, it's because I'm inside this. So let me hit cancel real quick. So you can always go up here, hit right click, and hit new component. And then that component you name, and then if you need a component underneath that, you can come down here and hit here, new component. So in the back of your minds, always remember that the components are to me, the most important way to properly manage a drawing. And try to think about the way you're going to actually filter the different components as you build it, so you can turn on and off certain parts and see different components. So let's dive in here a little bit and look at this design though. So what I did is I wanted to have a way to have basically brake shoes inside the wheels. So what I did was, let me turn this back on for a minute. And what I did here was basically this part of the rim, which it's a 3-part rim, and I'll tell you why I did this. This is ABS white material. This is a standard ABS white material, and this is actually carbon fiber impregnated nylon. Okay, so the reason I did it this way is that if you look inside here, let me turn off those and turn off my bearings. If you look inside here, you'll see that this is ABS. ABS has a much lower melting point than does the nylon. So my theory is, and I've mentioned this in other videos, is that these will wear without ever wearing the rim. And these can be replaced. I can print these off probably 50 to 100 at a time on my hotbed of my 3D printer. But what's really nice about Fusion 360 is I'm not looking at this right now in my mind as a bunch of drawn lines and wires and stuff. I mean, you all know, all my model aviation friends following me, that I've completely taught myself how to do Fusion by watching 2 or 3 of that guy's Lars webinars, and this is what having it for a couple of months can do for a model aviation enthusiast. But back to what's really nice is you're seeing these basically in when I used to draw in 3ds Max or other softwares, you always saw these as wireframes, and you always saw them as almost like CAD wireframes instead of a rendered type drawing. To me, this looks almost like rendered because you're seeing what it would really look like, and you can change whatever material surface you want to it. So one of the things to keep in mind is the way I designed this was these will wear out because they will actually melt, or I'm not really sure what's going to happen until I do testing, but I'm guessing that these are going to wear away or melt away way before the nylon will. Okay, now one of the reasons when I built this rim as 3 parts is these 2 sides here have to tightly sandwich against the tire. Okay, and the thing is I didn't know exactly what that was going to be, how much I could compress it without damaging the ABS. So this part here I made so I could change its thickness without ever having to change these 2 outside pieces to make sure I got the proper sandwiching of the parts. Okay, so I'm going to turn off the wheel for a minute and go back to the brake. So if you look at the brake here, these parts pivot on this. I actually have a 440, I can't remember what you call the type of the head on it. It's like a button head 440. And that shaft going through here is what gives this all this strength. So if I were to go into the brake system here and turn off the shoes, I had a couple people email me and say, Damon, there's no way that a 3D printed piece is going to be that tight. It is when you put a 440 button head screw through this, and I should have drawn that. I've drawn it in everything else. This piece was going to be ABS, but I ended up making it out of aluminum, 6061 aluminum, so it's not hollow, so I should have updated that too. So, but what I want you to really understand here is that this right here, and of course I didn't draw that right either, essentially, and I wonder if I could do that right now. No, I'm not going to. This hole goes all the way into this piece of aluminum here, and a 440 goes into it, so this won't rotate when the brakes hit. Okay, so just for illustrations, I'm not going to actually change my drawing here. So basically, if I take this and push it into the metal here and use it to cut away, right now you can see I got that hole going all the way into the aluminum. So what I would do here is have a 440 button head go into this too, and you'll see this in a video in a minute. That's what keeps it from rotating. Okay, so this essentially is my brake system. It's gotten, honestly, because of my inexperience in fusion, it really, I've done all these structures here wrong on the left. I mean, all the components. Now that I know how to draw with this better, I could do much better. Now, one thing is the cable that goes through this, that connects to this arm, that pivots to activate my brake, is almost like a bicycle brake cable. I mean, it's much, much smaller, but it actually will run up, and it fits loosely through this hole. So this is just a guide hole up here for that cable. The reason it's got to be loose is when this suspension moves, hang on a minute, let me see if I can do a section on this. So essentially when this piston here is riding up and down inside here, and you can't see how deep this piston is because it keeps this whole thing from rotating, but when this piston moves up and down here, the distance between these 2 objects changes. So when my cable runs through, is held in this, the outside cable jacket, it has to fit loosely in this so that when the suspension moves, it moves freely. Okay, so that's pretty much my design. I mean, it's set back the design of the C130 3 months because of just the testing, and hopefully this weekend, it's a 3-day weekend. However, I do have family game night, a couple of nights this weekend. We're all getting together for our friends, so that's going to take away from building, which is that kind of exciting buzzkill because, you know, I love doing things with the family, but I also love building this stuff. But I'm trying to think if there's anything else I missed here that I'm going to get more questions about. So now we're going to go in and look at the little video. And as the video starts right here, sorry, it took a while to get it rolling. You can see here as this is activating, that cable's pulling, it's actually pushing the brake pads out, or brake shoes. And that's what's going to cause it to work. Okay, and you can see up here toward the top of the cable where it goes through that loose fitting. You can see the brake's not engaged at all when I turn it like that. And that's one of the most important things, is not having friction that's building up heat. But here you can see I spin it and then I hit the brakes and it stops instantly. And so far this is working perfect, but I've had many of my designs work perfect, and then when I get into testing I realize they're turds. So hopefully this makes a lot of sense. I do have another video here, and This one kind of just explains a little bit more of how the actual system is held together. There's actually a rubber band that runs around circumference here, and that's what holds the brake shoes in, that little rubber band. And those little pads are just, I mean, those little brake shoes are so easy to change. They take me maybe 2.5 minutes to change. So I just take off the outside wheel nut, pull the wheel off. I'll take out that. You can see on the other side that 440 that runs through it, and I just remove it. So C-130 has 2 tires on each side, so I have 4 brakes on it, and I think all 4 brakes on it are going to help it work very well. There you can see the inside of the rim, and you can see that that's nylon. It's not going to melt nearly as soon as the ABS is the way I have it planned. Okay, those are ABS right there. So I hope this all makes sense, and I hope you enjoy watching my videos, and I hope you come back and watch them in the future. So keep the questions coming to me, and I will be posting soon. I'm trying to do a bunch of videos this weekend. Thanks, everybody, and have a wonderful weekend.